Oh, hi there. Don't mind me. Just sitting, performing a chemical reaction. You know, if I changed the rate of the reaction by putting the marshmallows closer into the fire...
Tim, bye-bye.
Tim, Hewed the Science Dude.
Tim, Hewed the Science Dude.
Tim, Hewed the Science Dude. Tim, Hewed the Science Dude. Tim, Hewed the Science Dude.
Brought to you by firefighters, always working to slow down that reaction.
Reactions are happening. Some reactions take longer to take place than others. This is where the rate of the reaction comes into play. The rate of the reaction is the speed at which a chemical or physical change occurs. The reaction can be sped up or slowed down depending on the factor that you add to it. There are 5 different factors.
Tim?
5 different factors that affect the rate of a reaction. The first factor is concentration. By increasing the concentration, it increases the number of reacting particles, making it easier for them to collide and speed up the reaction. This is like if there were more people in a hallway at school. There'd be a better chance of you bumping into someone with the increased amount of people. The second factor is pressure. Now, pressure is only a factor when it comes to gases. By decreasing the volume of the gaseous reactants, it increases the concentration of those reactants. This increases the effect of collisions, making the reaction occur faster. The third factor is temperature. 'Cause you're hot and you're cold. By increasing the temperature, it increases the kinetic energy of the reacting particles. With all the particles hopped up on energy, they move faster, increasing the chance of effective collisions. With all the collisions happening, the reaction occurs much faster than it would have. 'Cause you're hot and you're cold.
Sorry, Tim.
Let me show you something. This is a little thing we scientists like to call elephant toothpaste. Now here I have 2 bottles of different size. Both have half a cup of hydrogen peroxide, 1 teaspoon of dish soap, and food coloring for a little flair. Now I'm going to add this mixture of warm water and yeast into each of these to create a chemical reaction. But first... safety first. Now you see, the smaller bottle splurt out the toothpaste much faster than the larger bottle did. This is because there's more pressure on the reaction inside the smaller bottle.
Tim?
I'll be right back.
So, one man versus the increase of temperature, global warming, filled with drama.
Rice caps. Mulching.
Suspense.
Did you eat my taco?
And explosion.
I personally packed in there with my own 2. No.
Starring The Rock. Will he be able to survive the change in rates? Coming to a theater near you. Tim? You back on?
concentration, pressure, and temperature aren't the only things that affect reaction rates. The fourth factor is surface area. The more surface area that's exposed has more area for the reaction to occur. This increases the frequency of effective collisions, causing the reaction to speed up. The fifth and final factor is the addition of a catalyst. A catalyst is a substance that lowers the activation energy of a reaction by providing an alternate pathway for the reaction to occur. We're going to run two tests. We're going to heat up a stick of cinnamon, and then we're going to heat up cinnamon powder. When we were out there, you saw that the cinnamon stick didn't really do anything. It just kind of burned. And you saw that the cinnamon powder lit up in nice little sparkles. That's because there was more surface area with the powder, making the reaction happen a lot faster. Wasn't that amazing?
Is your solution boring?
Yeah.
Extreme, yes! Ah! It's a catalyst! What was that reaction rate? Yes! There's nothing that satisfies customers!
What are you doing in my house?
If you go down, get a free water bottle!
An inhibitor is the opposite of a catalyst. It slows down the reaction rate by blocking its path. As you can see, I have a rusty nail right here and a normal nail right here. That's because this nail was sprayed with an inhibitor called Z-Rust. It stopped the reaction from happening so quick.
No. Do 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 do. Do 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 do. Do 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 do.
This one for them reactions, them products, them reactants. This one for them factors that affect the rate that reactions do. Concentration, pressure, temperature. That's 3 out of 5 of the long drive of the facts to choose, remember. It's too hot,
Hot damn.
increase concentration and pressure, man. It's too hot,
Hot damn.
make a scientist wanna retire, man. It's too hot,
Hot damn.
say my name, effective collisions. It's too hot,
Hot damn.
and I'm bad about them equations. Break it down, speed it up, hallelujah. Speed it up, hallelujah. Speed it up, hallelujah. Reaction rate gonna give it to you. Reaction rate gonna give it to you. Reaction rate gonna give it to you. It's Saturday night and we change rates. Don't believe me, just watch. Come on. Ah! Don't believe me, just watch. Ah! Don't believe me, just watch. 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 Hey, hey, hey. Oh, stop. Wait a minute. Fill my cup, put a solution in it. Take a whiff, get a stick. Ramon, get the stick. Surface area, catalyst. 2 more factors that affect the reaction rate. Ain't that great? Smoother than my boys respect. It's too hot.
Hot damn.
Exposed area for the reaction, man. It's too hot.
Hot damn.
Add a catalyst, different pathway, man. It's too hot.
Hot damn.
Say the name, effective collisions. It's too hot.
Hot damn.
And I'm bad about them equations. Break it down now. Speed it up, hallelujah. Speed it up, hallelujah. Speed it up, hallelujah. Reaction rate gonna give it to you. Reaction rate gonna give it to you. Reaction rate gonna give it to you. It's Saturday night and we change rates. Don't believe me, just watch. Come on. Ah! Don't believe me, just watch. 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 Hey, 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 ow! something. Reaction, speed it up. Reaction, speed it up. Reaction, speed it up. Reaction, speed it up. So reaction, speed it up. Reaction, speed it up. Reaction, speed it up. Reaction, speed it up. Come on, dance, hop on it. You experiment, then flaunt it. Use factors, then own it. Don't brag about it, just show it. Come on, dance, hop on it. You experiment, then flaunt it. Well, it's Saturday night and we change the race. Don't believe me, just watch. Come on! Ah! Don't believe me, just watch. 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 Hey, hey, hey. Oh, reaction, speed it up. Reaction, speed it up. Say what? Reaction, speed it up. Reaction, speed it up. Reaction, speed it up. Reaction, speed it up. Say what? Reaction, speed it up. Reaction, speed it up. Reaction, speed it up. Reaction, speed it up. Say what? Reaction, speed it up. Reaction, speed it up. Reaction, speed it up. Reaction, speed it up. Say what? Reaction, speed it up. And there you have it, the 5 factors that affect reaction rates. Concentration, pressure, temperature, surface area, and a catalyst. Well, I'm Tim, signing off.
It's been a long day without you, my friend, and I'll tell you all about it when I see you again. We've come a long way from where we began. Oh, I'll tell you